This is Mr. Parks, and today we are going to talk about multiplicity. And I've already made a video that goes over the basics of multiplicity, but what we're going to do today, so I've already made a video for everything before this point, so here and on up. What I'm going to talk about is focusing on how to write the equation of a graph. Now, before we write the equation, I want you to know that we don't have exact values here, and there is a way to get the exact equation, there is, but I just want an approximate, okay? And so when I look at this, first thing I notice is that it points up on the right. Now, what does that tell me? That tells me that if it points up on the right, that it has a positive leading coefficient. Okay, so this first number is going to be positive. We don't know what it's called, y, maybe f of x. I'll go with f of x. So I would say f of x equals, and we know it's going to be a positive. Okay, and now if this is pointing down, it'd be negative. Okay, now we look here and we see that right here is what we call a bounce, so it doesn't go through, it kind of goes, it just bounces there. And remember what that means. Anytime that happens, that means the multiplicity is of at least 2. It's of even multiplicity, so it could be 2, 4, 6, 8, and so on. Just to keep this simple, I'm just going to stick with 2. Now, this solution is 2, which makes the factor x minus 2, because 2 minus 2 is 0. And so what I know is that this is going to be x minus 2 of at least second power, possibly fourth, possibly sixth, but I'm just going to put a 2. And then down over here at negative 1, so that's negative 1. So if the solution is negative 1, the factor is x plus 1. And because it goes straight through, that means the multiplicity is of odd degree. Could be 1, 3, 5, 7. Normally, if it's anything bigger than 1, it would do like what I call a squiggle. It looks something like that, but ours does not. So I'm just going to say it's to the first. So it'd be x plus 1 to the first. And if you want to put a 1, you can. You don't have to put a 1. Now let's check our work. Okay. I have degree 2 and degree 1. So that's good news. That's degree 3. 2 plus 1 is 3. And that's good news because notice it opens up and down. So since it opens up on the right and down on the left, that means, excuse me, that means the degree should be odd. And my degree is odd. My degree is 2 plus 1. So that's a good sign. Now let's go and just really check it. What's that called? Desmos. Now let's see. Does mine look? So I don't really need that positive out front, but I have x minus 2 squared. Ooh, there's my bounce. And x plus 1. Do those look the same? My y-intercept is 4. Their y-intercept is 4. So I feel good. And my x-intercepts are the same. Now, if your y-intercepts don't match up, it's okay. Like you could add a number out. See, if I added a number, it just kind of makes it skinnier. Or maybe I need to make it a little fatter to move down that y-intercept. But I'm more worried about the x-intercepts, okay? And if I needed to flip the whole thing over, I could put negative and it goes, flip over to the x-axis, okay? So really it's just positive or negative is what I'm focused on, and making sure that we have a bounce here and it goes straight through there, which mine does. They look the same. Well, that one's red, that one's blue, but we're not talking about colors. Number two, I notice that it goes up on the right. That means my leading coefficient should be positive. Positive something, positive 1, positive 2, who knows? And then I see that it goes up on the left as well, so my degree should be even. Now looking at all this together, I have this as 2. I'm gonna have to make that blue. So this is 2. And remember, 2 makes the factor x minus 2. And because it's a bounce, bounce, that's got to be of at least 2 degree, or it could be 4, could be 6. Let's just go with 2. And then over here on the right, I have negative 2. So I have negative 2. So that makes the factor x plus 2. And it's a bounce, so it should be of even degree. So I'm going to put x plus 2 squared. And ignore my chicken scratch. Now I add those, 2 plus 2 is 4. That makes even degree. That makes me feel good. That means if it opens up on the right, even degree means it opens up on the left. Let's go check our work. X, ooh, delete. X plus 2 squared. Got my bounce. Oh, that was x minus 2 squared. And x plus 2 squared. Okay, notice they look pretty much the same. Looking at my y-intercept, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I think that's 16. Looking at mine is also 16. But again, I'm not so worried about the y-intercept, but if you needed to move it down, you could do like 1/2, see how that moved it down. Or if I wanted to move it up, I could put like a 2, which brings it all the way up to what, 32. So I'm not as worried about skinny and fatness as I am that it bounces here, and has the proper x-intercepts. So that's 1 and 2. I did that for you. I'll let you finish 3, 4, 5, and 6 yourself. Excuse me. Now down here below, I did cross some off. I do want to do at least one example for you. We're going to answer these questions. We're going to do the first one. Find the real zeros. Let's be A. What are the real zeros? Well, for x plus 4, that'd be negative 4. For x minus 2, that'd be 2. And for x plus 3, that'd be negative 3. And just to make it easier to see, those are my real zeros, okay? Now, what's the multiplicity of each zero? Well, this is to the first power. Right here. So I would say for negative 4, multiplicity is 1. This is to the first power. So for 2, multiplicity, and you're supposed to spell out multiplicity, but I'm being lazy. Multiplicity is 1. And for 3, exponent is 4, so I'd say multiplicity 4. Okay, so this goes with that goes with that goes with that. B. B. Determine whether the graph crosses or touches the x-axis at the x-intercepts. Okay, so whenever the multiplicity is odd, it crosses. For odd is also cross. And for even, that's when it touches. I like to call that a bounce. Okay, it doesn't cross through, it just touches, a bounce. Okay, number C. Determine the end behavior. Oh, all right. So as x, if I remember this short codes, 26, as x goes to the right, what happens? What's my function called? F of x. What does my function do on the right? And as x goes to the left, oh, not that. As x goes to the right, we'll do that one as left. F of x does what? I keep pushing the wrong button. 26, Alt 26, there we go. So let's think about that. So to do C, the end behavior, first I notice that this is negative. Negative means on the right, it's going to open down. So to say it opens down, instead of down, I put negative infinity. Okay, on the right, it goes down. Why? Because that negative. Now, I'm going to type in, oh wow, undo, undo. Whew, that would have been bad. So it's kind of hard to see. So I'm going to move that over there. That makes it look better. Now, this is when you're going to type on the left. So on the left, it'll also go down if the degree is even, but it's going to go up if the degree is odd. So how do you know the degree? You could just add the multiplicities together. 1 plus 1 plus 4, 6. That means my multiplicity is of even degree, which means this is going to go down also. So to say it goes down on the left, and it probably looks better to actually draw it going down on the left. To say it goes down on the left, I also put in negative infinity. Okay. Now, sketch a graph by hand. Okay, we could do that. My zeros are at -4, right there. -4, and at 2, and at -3. Okay. Now, I also know, and this is going to be a terrible sketch, but we just said it goes down on the right. So it's going to go down on the right, something like this. Try again. So I know it's going to go down on the right over here. And it's also going to go down on the left here. Okay, and at -4, 1, 2, 3, 4, it goes straight through. It crosses, so it's going to cross. So it's going to go over this. And then at -3, it touches. So it's going to go cross through. It's going to come back up, and it's going to touch. So it's going to go back up, and then it's going to go up, and then come back through. Okay, so crosses, crosses, touches. Now this is a very ugly looking parabola, and I'm okay with that. But let's go check our work. Negative x plus 4 x minus 2 and x plus 3 to the 4th power. So so it's not going to look exactly the same, but notice it's going down on the left, down on the right. Mine is as well. Notice it goes straight through at -4, but bounces at -3. Goes straight through at -4, bounces at -3. Or you could say, what word do they use? Touches instead of crosses. And then it goes back up and it comes straight through at 2. Now, does mine look like theirs? No way. But does it have the same properties? Yes. It goes through, or it crosses, it touches, it crosses, and it has the same x-intercepts. Now, if I wanted to play around with this, I mean, I could plot some points, get some exact points, but I don't want you to worry about that. But I hope that's enough to get started. Okay. Good luck to you. Feel free to email me if you have any questions. I will see you later. All right. Bye-bye.